Hello, my name is Matthew Bevan. This is my video for my black box testing for my NEA, which is a 3D rendering engine using ray tracing. The first section in my black box testing is section 1, graphical user interface and input validation. The first test of which being a general GUI test, testing that adding an object and material result in the appropriate change to the GUI. There is no test data here. The expected outcomes are that the list box should contain new object and the material combo boxes should contain new material. So I will start by running the program. Here. Now if I press add object, since there are no materials currently, it would add a material. So I'm going to press add a material first and then add an object. As you can see, it was added to the list box. There is a material in the object's material, and there's the material in the material editor. So this passes. This next test is testing that changes to the properties of an object or material are saved when switching to editing another object or material, and all the inputs are validated. So I'm going to start with the typical data, which is a color value of FF0056, a radius of 3, change the name of the sphere to sphere 1, switch the render checkbox off, and change its material to a second material. So, to start with, change the material to FF0056, which has been accepted. I'm also going to change the name for the time being, just to make it clear later on. So I can now add a second material. It appears as new material, and the changes are saved between. Now, if I do the same for an object, I'll first change the radius to 3, change it to the new material, change the radius to 3, change the name to sphere 1. As you can see, it's changed up in the list box as well. And now if I add an object, you can see it's got the first material, the sphere has the second material, I forgot to check the test box off. There we go. Now the render mode is also being changed. So typical passes. Erroneous data is any special character. In all cases, that will not be able to be typed in. So if I attempt to type in a question mark, you can hear the button pressing hopefully, and it's not letting me type. If I attempt to type any letters into a number, it won't let me. Same goes for attempting to type a special character into a name. So erroneous passes. Now, extreme data is having a radius of -1 and attempting to enter a blank value or an incomplete Hex code. So I have two blank values here. If I press enter, they should be filled in with blank name and 0.0 respectively, as they have been. If I attempt to enter a radius of -1, it is accepted. Although intuitively it does not make sense to have a negative radius, mathematically it does, so it's accepted. And if I attempt to input an incomplete color value, then it should fill it in with zeros. This also goes for if there is no entry at all. All color values use the same validation, so do all name places, and any numerical data also uses the same unless it can be negative. For example, a camera's resolution cannot be negative. So extreme passes as well. next test is changing an object's type. So testing that changing the type of an object copies the appropriate data to the new object. So a sphere will be, here I'm changing a sphere from a camera. In this case, the rotation and the position of the sphere should be copied over. So I'm going to enter a random position and rotation. And when I change the sphere to a camera, which will take a second, it should keep that position of 1, 0, 2, 0, 45, 18. As we can see, that has been maintained. So this test passes. The test for deleting an object should remove it from the collection, and it should no longer be able to be edited. So if I delete this camera, it has been removed. I can no longer edit it. Therefore, this passes. A test for importing a mesh is testing if importing mesh correctly accesses the geometry data and the file is moved to the mesh folder. So I have 3 sets of data here. Typical is a cube.ply file and an icosahedron.ply file. The erroneous is a cube.txt file, and then extreme is a cube.ply file that has already been, I meant to change that, that is already present in the folder. So if I attempt to import, here we can see the cube.ply file. If I open it, then in this drop down menu for the object type, a cube should be there, which it is. The same should go for icosahedron, which it is. If I attempt to import cube.txt, which is this document here, it should prompt me saying can only import PLY data, and it should allow me to import again. Now, if I attempt to import the cube.ply file, it should allow it if this file, if this file actually included different data, then it would overwrite it. But as we can see, this is the PLY file. All data has been copied accurately, which shows that this test passes as well for all instances. The next section is section 2, which is the main algorithm/processing testing. The first test here is simply testing that changing the render modes will result in a different image. We don't care about what it will result in, just that it produces a different image showing that it uses different processes. So if I actually add something to view the scene with by adding a camera and add a sphere in front of it. Now, if I'm going to lower the camera's resolution for the sake of time. If I hit this when the render box is checked, then it will produce a full render. This will take a few seconds. It will prompt me to save the image, which I can save as test image.jpg. Yes, I would like to replace it. Great. And it will show the image. So as you can see, it's a black screen. If I now uncheck the render box and press the button again, it will prompt me to save the image. If I save it as test image again, the image is saved. And it has now done essentially the same image as the viewport render. So this passes. The next test is testing that when adding cameras, the last selected camera's view is displayed in the viewport and each camera's view is exported when rendered. There is no test data for this, it's just that, that the expected outcome is that every time the camera is selected, it should switch to that camera's viewport, viewpoint, and when the image is rendered, it should ask you to save multiple images, one for each camera. So I will start by increasing the resolution. Now I'm going to add a second camera. If I position this directly above the sphere, we should see a different viewpoint looking down at it. So that is the sphere from the top, and when I change it, when I select the other camera, we see it from the front. Now if I hit render, and I'm going to do grey box again for the sake of time, that should be prompted to save 2 images. So test1.jpg, which should be brought up, which it is, and now it's prompting me to save the second image, test2.jpg. The image has been saved, and it has done both cameras' views, which shows that this test also passes. The next test is testing in the viewport that mesh objects are correctly displayed. The typical data is a cube object. The erroneous, there is no erroneous data here, as it would be, you cannot do an erroneous data as it would not be accepted. And extreme, testing an icosahedron, which has a larger poly count as a cube than a cube. So if I change the sphere to a cube, you should see it's not very clear as we're looking at it front on, but that has been accurately represented. If I rotate it, you can see. Now for the extreme, if we add an icosahedron there, you can also see that the icosahedron has been correctly represented as well, showing that meshes pass. Rotation and scale. Testing to check that the scale and rotation affects objects in the scene intuitively and accurately. So for the typical, I am going to be using a cube that has been scaled by a factor of 2 along its x-axis, and a sphere that has been scaled along a factor of 0.5 along its x-axis, and 3 along the y-axis, and a duplicate of the cube rotated 45 degrees on the z-axis. So this will take a second to set up, so I'm going to pause. So I've set up the scene. As you can see, the icosahedron has a, ignore the position, that was simply to separate them out, has a scale of 0.5 on the x and 3 along the y-axis. We have the first cube, which has a scale of 2, and the second cube, which has took a while to load, which also has a scale of 2, but it's been rotated 45 degrees along the z-axis, as you can see by it being diagonal, showing that the typical data here passes.